Hello, this is Malachi Bishop, and this is RC-750 Rehabilitation Counseling Research and Program Evaluation. This is week 4, and this discussion today will conclude our week 4 sections. So we are reaching the end, except for statistical decisions, of our quantitative research project. We've moved through these steps, and now we are going to talk in this section about procedures, methodology. What are the best procedures to answer my research questions? And we're going to do that specifically by talking about internal and external validity and reliability. So we're going to revisit an issue that we've talked about before. We talked about validity earlier this week, but we talked about it in a different way. We talked about test validity, which refers to the validity of knowledge claims that we can make based on a test or a measurement instrument. So does this test that I'm using, does this instrument that I'm using measure what it purports to measure? So we talked about defining validity that way. But now we're going to be talking about a different way of thinking about validity, internal and external validity of the research itself. So we're talking about research design and research methodology. So in this section we'll be talking about internal validity and external validity, and the idea in internal validity, the extent to which the researcher can attribute changes in the dependent variable to the independent variables, is that we want to make sure that there are no other issues or other variables or other factors that affect that relationship. In other words, when we do a research study, whether it's a survey where we're trying to find out if older people have different attitudes than younger people, or if it's an experimental study where we want to see if a group that has exposure to some intervention, like watching a film, shows different results than a group that didn't watch a film, we want to be able to say that the differences that we found are based on our independent variables. So age of one group and age of another, or whether they watch the film or not. We don't want to have to worry about the fact that our samples are not distributed evenly or in a way that clearly distinguishes between two groups. We don't want to have to worry about researcher bias or a variety of other potential threats that we'll talk about. We want to be able to say that there is a difference, and the difference is a result of differences in the levels of our independent variables, differences between the groups, differences between the interventions, and so on. So this is really about paying attention to our research methodology, the way that we conduct our research, so that we can say with confidence that the differences we find are based on the differences in our independent variables. And then we will also talk about external validity, which has to do with how well we can say that the findings in our sample can be generalized or are also true for the larger population. And that's a different issue, and we're going to spend some time talking about that as well. But let's first, we're going to focus on internal validity and what that means and what some of the threats to internal validity are that we can watch out for. So, internal validity determines the confidence that we have in saying that the changes we see in the dependent variable are due to changes in the independent variable and not to other factors. These other factors might occur through problems in the sampling, the measurement of the variables, the research design, the analysis, or the conclusions. Internal validity is achieved through experimental control. That is, through allowing nothing to differ systematically between the experimental conditions other than the independent variable. So you want the only systematic difference to be the difference that you're interested in looking at. If something other than the independent variable differs in some systematic way, then we would call that factor a confound. And when confounding occurs, there's no way to know whether the results are due to the independent variable or that confound. And to help you understand this idea of a confound a little bit better, I'm going to show you an example. Here we have two glasses of cola. The picture represents a taste test, and this is based on an actual situation, an actual taste that was done between two colas. I don't remember what they were, but one company wanted to find out if their cola would, people would say their cola tasted better than a competitor's cola. So they set up these tables, and they had two glasses identical to each other, and they filled one up with their cola and filled the other glass with the competitor's cola. And they had a card on the table marked M for their own cola and Q for the competitor's cola. And people would come along and they would take a taste of one and then the other, and they would say, which one did you like better? And the results suggested that more people liked the M cola. So now you have an experiment. You have collected data, and you've found that your cola was preferred to the competitor's cola. Statistically significantly more people like your cola, so that's great. You can say your cola tastes better, except there's something that happened in this study that makes that a problem. The M and the Q were always on the same glasses, so the M was always on your cola, and the Q was always in front of the competitor's cola. They didn't mix those up. They didn't sometimes have the M where the Q is and the Q where the M was. So they always stayed the same. So they systematically varied along with the independent variable, which was the cola, which cola you're tasting. If M was always in front of brand X and Q is always in front of brand Y, then this is another variable besides the independent variable, which was the taste of the cola, that varied systematically and that could affect the results. And it turns out that the reason this is an issue is that it's possible that people would prefer the letter M to the letter Q. And so it could have been that people just liked M better than Q. And you have no way of knowing whether that was the case, so it could, because the researchers didn't mix those up. So there was a systematically varying alternative variable got in the mix, and so it's impossible to say whether the results were due to the taste of the cola or the preference for the letter M. So that's an example of a confound, a variable that systematically varies with the independent variable, and clearly in this case it can make it more difficult to state your results with confidence that your cola tastes better than the competitors in this case. Let's look at some of the threats to internal validity. The first one is history. And history refers to an outside event, which could be a life experience or some unplanned event that influences subjects in the course of the experiment, or between repeated measures of the dependent variable. So in the latter case, if you are collecting data over time, maybe every month you are collecting data from the participants, then something is happening in the lives of the participants that could influence the results of your study that is outside the confines of your experiment. Some life experience, some unplanned event, something is going on outside. So let me give you an example. Let's say we came up with a new job placement method, and we developed that in 2008. We're very excited about this new job placement approach, and we want to see how it works. So in 2008, we evaluated our new job placement method. And the way we did that is by comparing it with how we previously did job placement. So we have some data from 2006 with our old way of doing job placement, and then we collected data in 2008 with our new method of job placement. And let's say the way we measured the difference was how many people are getting placed. So maybe percentage of people that we are working with, we're looking for a difference in the percentage between the old way and the new way. And we find that the new method does not show good results. So disappointing results. What could have happened there? If you think about what happened between 2006 and 2008 in the US economy, the economy really took a dive and went downhill, and unemployment rose significantly, and hiring dropped in 2007 and 2008. So the results from 2006 wouldn't really be comparable with the results in 2008. So this is an example of something external to the experiment, some unplanned event that resulted in fewer people getting hired despite our new job placement method, and so it affected the results of our experiment. So that's an example of history as a threat to internal validity. And now we can't say with confidence that our method is better or worse because the outside conditions are so much different. Instrumentation is another threat to internal validity. And here the reliability of the instrument that we are using to measure the dependent variable, to gauge the dependent variable or manipulate the independent variable. So the instrument that we're using to measure the variables may change in the course of the experiment. The reliability of the instrument changes. And the question here is, how can an instrument become less reliable? And usually what we're talking about here is when the instrument is a human observer or rater. So the human is the data collection instrument, and the reliability can be affected in a number of ways. Maybe they got better at making recordings after they had more practice. So over time they become increasingly good at making those observations and ratings, and so the reliability changes over time. So any findings from time 1 to time 2 would be based on the reliability of the instrument changing, or could be based on changes in the reliability of the instrument rather than our differences in our independent variable. It could be that they get tired, or they become biased against a later group compared to an earlier group, things like that. Or with any sort of instrument, remember we talked about a variety of sources that can affect the reliability of an instrument. So basically any other source of error can increase, and so when you have changes in the reliability of the instrument over time, over the course of the study, then we're talking about a threat to internal validity in the form of instrumentation. Maturation is another threat, and this refers to the idea that basically people change over time, right? We're all growing and changing, and in this case subjects may change in the course of the experiment or between repeated measures of the dependent variable just due to the passage of time, psychological or physical development. So the participants actually change over time, and so again our results are affected by that. Repeated testing is another threat to internal validity, and here the issue is that the prior measurement of the dependent variable using some instrument may affect the results obtained from subsequent measurements, and the idea here is just the fact of taking the test or completing the instrument the first time makes it it affects the way you take it the second time. Maybe you do better because you have had some practice. or there are a variety of ways that the second measurement could be different. It could be faster. You could have thought more about it and came up with answers that you wouldn't have come up with if you hadn't taken it before. So any issues like that result from the fact that you already completed the measurement, completed the instrument or the test, and now you're doing it again. That would be another threat to internal validity. The ability to say, again, that the results that we got were based solely on the changes or the differences in terms of the independent variable. Selection is another issue to think about. And here the issue is that we assign subjects to comparison groups, such as the control and the experimental group, for example. And the assignment results in unequal distribution of some characteristics that affect the results. So, for example, even if we did random sampling, it's possible that one group is going to be different from another in some characteristic that affects the results. And so, for example, the age of one group might be a lot higher than the other group, or gender differences, or ethnicity, or all sorts of things. But basically, somehow the groups were different. They were unequal with respect to some participant characteristic that's important to the results and how people responded. And then statistical regression to the mean. And this is the idea that if you complete a measure and then complete it again in the future, your scores the second time will generally be closer to the mean for the instrument. If they were higher the first time than the mean, they will be lower and closer to the mean the second time. And this is just an interesting thing that happens when you give groups of people an instrument more than once. So subjects with extreme scores on the first measure of the dependent variable tend to have scores closer to the mean on the second assessment on that instrument. So if you find the first time that scores are much higher in the experimental group than in the control group, but then the second time they are much closer to the control group, you're not sure if the difference that you're seeing is due to some experimental condition or the simple fact that scores will regress to the mean. Experimenter bias is another potential issue. The idea here is that expectations of an outcome by persons running an experiment may significantly influence the outcome. So again, here this is the human factor coming into play. But if you are an experimenter and you have expectations about how the results will look when it's over, then your bias may actually affect the results. Either consciously or subconsciously, you may do things differently. You may ask questions differently, or look at the data in such a way that your bias actually affects the outcome. And so, again, that would affect the ability to say that the results are due to the experimental conditions and not due to bias. And we can deal with that to some extent with things like blinding the researchers so they don't know which condition they are working with. So there are some ways to get around that, but it is a potential threat. And then the last one, social desirability. And this is the issue of people generally want to represent themselves well. They want to look good, and they don't want to look bad. So participants who are have an opportunity to make themselves look good will usually do that, and that might affect your results. So answers are given in a way that is based on the way people want to represent themselves rather than as they really are. So for example, this is particularly an issue in attitude research, and so a question like, would you hire a person with a disability? If you were asking employers this question for legal and personal and professional reasons, they may indicate that yes, they would hire a person with a disability. But in reality, maybe they would be less likely to hire a person with a disability. But they're happy to tell you, in response to your question and your research, that they would hire a person with a disability. It's the socially desirable response. Again, there are ways of dealing with this threat, as with all of these threats, and in this case, anonymity helps a lot. So if you ensure people that their responses will not be associated with their name, so in other words, nobody will know how you answered the questions, your responses are anonymous, then generally people are a lot more willing to be honest and say how they really feel, rather than worry about presenting themselves in a good light. Okay, let's look now at threats to external validity. And remember, when we talk about external validity, we're talking about the extent to which factors affect generalizing your results from sample to populations across persons, settings, and times. So in terms of persons, a threat here to external validity is the interaction of selection with treatment. And in this case, the participants are selected in such a way that the results are not generalizable. So changes resulting from the independent variable, the results, are affected by the way that the participants were selected. For example, this happens a lot with survey research, where the sample is voluntary. So you send out a lot of surveys to a population, but the people who respond to your survey frequently are people who are motivated to respond. And I'm sure you've all received requests to complete a survey. And a lot of times, if you get an envelope in the mail, let's say, or an email invitation to complete a survey, we'll just throw that away. Not likely to do it, unless it's about something that we feel strongly about, or we're interested in, or just are really bored, or maybe if there's a good reward or some incentive for us, then we'd be more likely to do it. We'll talk about that in a couple of weeks when we talk about survey research. But not everybody is going to complete a survey, but the people who do, a lot of times, are people who are motivated, either because, let's say, they're very happy with the service, or else they're very unhappy and they want to let people know how unhappy they are with the service. So in a case like this, the results that you get from your sample would not really be generalizable to the larger population. You couldn't say what you found from these people who were very happy that the population felt the same way. So that would be an issue in selection of participants. Another threat to external validity would be interaction of setting with treatment, and this is a settings issue. Interventions in one environment do not necessarily transfer to other environments. So for example, if you're bringing people into a laboratory and you're doing some intervention in a clinic or something like that, you may get results that are different from how people actually act in the real world. And so you can't be sure that the way your participants are responding in your setting are reacting the way that people out there in the real world would react and respond. So you can't say that your sample results generalize to the larger population. And then the third issue is interaction of history with treatment, and this has to do with times. And basically the issue here is that the results do not generalize across time. For example, attitude research about persons with AIDS. Attitudes have changed quite considerably in the last 30 years about AIDS and people with AIDS and HIV. So you couldn't say that a sample of people who responded, let's say employers who responded to a survey about hiring people with AIDS in 1988, would still generalize to the population of employers now in the present. So the idea here is basically things change over time, and so it's a history issue. And that will conclude the threats to external validity. So the lesson here is to think about, again, these methodological issues, things that could come up with things like sampling and measurement and analysis of your results. And these are things that it's important to think about beforehand. A lot of times you can't think about it beforehand, but there are things that you can do to make sure that you avoid some of the mistakes that people have made in the past. So things like blinding the researchers to the conditions of the experiment, making sure that you select your sample in such a way that there are not differences between the groups, things like that. So this is a list of things that you can watch out for in conducting your research and pay attention to before conducting your research, that will save you trouble in the future, and that will really allow you to say that the results that you find are based on your experimental conditions. And that will conclude our week 4 discussions.